This is section 12.1. It's an introduction to statistics. Statistics is just the science of data. It involves collecting, classifying, summarizing, organizing, analyzing, and interpreting numerical information. We are only going to do a little bit of this. So a couple other definitions we need to see. A population consists of all elements whose characteristics are being studied. So the population could be the students in the class, or the population could be the kids at the daycare center. Sample is a portion of the population selected for study. So for our classroom example, I might just pick the girls, or I might just pick the boys, or I might just pick the front row. With the daycare center, I might just pick the 3-year-olds or the 4-year-olds. Most of the time, the population being studied is too big to use, so a sampling of the population is used. And this is very important. When you are doing a study and you are sampling the population, you need to have a random sample. And it is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. Like, go back to the classroom example. If I just pick the boys over 6 feet, then I am not picking a random sample. If I am just picking the 3-year-olds with blue eyes, I'm not picking a random sample. So let's take a look at these and see which is a random sample. So we're going to have hotel owners in a large city who are interested in how the city's citizens feel about casino gambling. Which of the following would be a most appropriate way to select a random sample? So A says, randomly survey people who live in the oceanfront condominiums in the city. Is that random or not? Well, if they're just the people in the oceanfront condominiums, you are not getting a sampling of the whole city. So this is not a random sample. Survey the first 200 people whose names appear in the city's telephone directory. That's not random because you're just getting the people whose names begin with A or B. Randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods. That would be a random sampling. A frequency distribution is just a way to display the data. The main thing we're going to do in this video is show you how to display and or graph data. In section 12.2, you will do some statistics calculation and some interpreting. So we're going to do a frequency distribution for this data of the age of maximum yearly growth for 35 boys. So this is saying that this is when those boys hit their maximum yearly growth. Well, you need to look through here and look at the ages. So I look through here to get started and see that my lowest number is 10, and I see that the highest number is 18. So this chart needs to go from 10 up to 18. That's the first part, getting all of these data numbers listed in a line here. Then the next thing you want to do is count up how many you have. Now, 2 ways to do this. You can do tally marks. You can say, okay, here's a 12, put a tally mark. Here's a 14, put a tally mark. But that, to me, takes a lot of time. What I do instead is I start with this first number, 10. And I look through here and count up how many 10s I have. But as I count, I cross them off. There's a 10. You see any more 10s? Nope, the frequency is 1. The next number in the chart is 11. So go through here looking for any 11s, there we go, 1, 2, 11s, and so on for all of those. Now to save time in this video, I'm just going to show you a completed frequency distribution. You could stop the video and fill all this in on your own if you want, if you feel like you need practice at that. But there is our completed chart. So that's one way to display this data. When the data is just listed like this, you can't tell much about it. But once you put it in a frequency distribution, you can tell some things about it. And you might have to make a graph out of that information. Now, this is the same information I had on the last page. It just looks neater because it's typed. We're going to make a histogram, which is like a bar graph. You might be familiar with that. But it's just going to be a graph that is going to display this data. The vertical axis gives the relative frequency for each interval of data, while the horizontal axis is divided into specific intervals. See, our numbers went from 10 to 18, and that's what I've got listed right here. In the histogram, each column shares a side. So in a bar graph, you made these bars that were separated a little bit. In a histogram, they are side by side. Now, I'll do a couple of these bars, but this is kind of hard for me to draw on here, and then I'll show you a nice one. So a maximum growth at age 10 was just 1 kid. So that's the bar for him. The 11-year-old has 2 frequencies, so I need to play right off of that side, go up to 2, come down. 12 all the way up to 5. And all the way down. And I should be making these bars the same width. It's just very difficult with this little pen I'm using. So what that will look like is this right here. This matches the data that was on the other page. So you see the nice little bars, they're the same width across. They are touching each other. And that we can tell looking at that graph that obviously the 14-year-old age is when most of these boys hit their maximum yearly growth. We're going to take this bar graph and make something called a frequency polygon, also called a line graph, can show you what the relationship here. And what you do with this is you put a dot right in the middle of each of these boxes. And then you're just going to connect the dots. So connect the dots. And you do connect them up with lines. I can't do this very well. And then down to the axis down here. So this is what the line graph would really look like. Those are the nice lines that I'm connecting those dots down to here. Now the cool thing on a line graph is this. I can take this bar graph away. Just take the bar graph away and that is my line graph. It looks pretty pitiful, but that is my line graph. And that's what you see right here. All right, something else we're going to do is take data, and instead of doing all of these tally marks like we did back here, we're going to group these things into little classes. So with these numbers, I've chosen to group these in increments of 10. I could have done increments of 5. You get to choose. So when you create from scratch, you decide on what's called the class width first. So we've got from 40 to 49, 50 to 59, and so on. If you got a lot of numbers, you don't want to have a teeny tiny class width because you're going to be there forever marking the frequencies. So I will do the same thing. Now, my lowest score is 43, and that's why I started with 40, and then I just counted by tens. Before we do this, let's look at these definitions. The lower class limit is the leftmost number in each class. So this is the 40 to 49 class. This is the lower class limit. The upper class limit is the rightmost number, so 49. So for this class, the lower limit is 40, the upper limit is 49. The class width is the difference between two consecutive lower class limits. So the class width is a matter of subtracting those two. 50 minus 40 is a class width of 10. If I maybe pick these two, 90 minus 80 is still a class width of 10. So that's what class width is. Class width is not the difference between the front and the back here. It's not 49 minus 40 because that would have given us 9. So back to the frequency, we just have to start making little tally marks here. So 82, there's one there, cross it off. 47 goes there, cross it off. 75 goes there, cross it off. And yes, that's very boring and tedious, but that's what you have to do with these. So you can stop the video, make your own if you want, or look here, and this is where I did the tallies off screen. And then I have a total. These are the tally marks, just making those little marks. But the frequency is 3, 6, 6, 11. That's not 2 tally marks. That's an 11, 9, 5. So let's look at a couple problems here. The government of a large city needs to determine whether the city's residents will support the building of a new middle school. The government decides to conduct a survey of a sample of the city's residents. Which of the following procedures would be the most appropriate for obtaining a sample of the city's residents? Remember, we really want a total random sample. So let's see if any of these is random. Survey a random sample of adults who currently have children in public schools. Is that a fair survey? No, it is not, because it's only hitting the parents. How about all the people that don't have kids in the public schools? They have a vote in this. Survey every third person who walks into the local grocery store. Is this a total random sample? No, it's not. It's just sampling the people who happen to shop at that particular grocery store. Survey the last 100 residents listed in the telephone directory. Well, if it wasn't good a couple of screens ago to survey the beginning of the telephone directory, it's not good to survey the last, which leaves us with this, but let's read it. Survey a random sample of persons within each neighborhood. That is covering the whole city randomly. So this is our random sample. All right, a questionnaire was given to students. The first question asked was, how stressed have you been in the last week on a scale of 0 to 10, with 0 being not stressed at all and 10 being as stressed as possible? and here's the responses. So which stress rating describes the least number of students? All you have to do is look through here, find the lowest number, which is right there. And it asks which stress rating. The stress rating is a 2. And how many students responded with this rating? 1. A professor had students keep track of their social interactions for a week. The number of social interactions over the week is shown in the following grouped frequency distribution. How many students had at least 80 social interactions for the week? At least 80 would be all of this on down. So we add this up. 3 plus 7 plus 4 is 14. So 14 students had at least 80 social interactions for the week. All right, this one looks rather busy here. A professor had students keep track of their social interactions. The number of social interactions are in the following grouped frequency distribution. And instead of it running vertically, it runs horizontally. It's still the same data. Construct a histogram and a frequency polygon for the data. Notice we've got multiple choice here. You don't have to construct your own unless you really want to. So it's a matter of picking which of these is the correct histogram. What I do is look at numbers that might help me eliminate. Like C is all the way up at 20. Do I have a C up at 20 here? No way, I don't have a C at all. That rules that one out. Do I have a C up at 20 here? Nope. How about a C up at 20? Yes. C up at 20? Yes. So both of those are still in contention. I also notice that this I situation is 0. Do we have an I that's 0 here? Yes. Do we have an I that's 0 here? No. So this is my answer. Also, notice in this chart, the social interactions group between 10 and 14 is called Group A. Between 15 and 19 is called Group B. And the reason they do that is that it is much easier to fit in A, B, C down here than have to try to write in 10 to 14, 15 to 19, etc. So that's why the letters are there. Now I need to take this and see if I can find which of these is the correct frequency polygon. And it's the same thing. The main thing I looked at is that this I is 0. The only one where I is all the way down to 0 is right here. This is kind of hard to see on this screen, but when you're doing your homework, if you click the little magnifying glass, it will blow it up for you. All right, there's something called a stem and leaf diagram, and it's another way to organize data where you can see the original data, but it's sort of a shortcut. The stem is the number in the tens place, and the leaves are the numbers in the ones place. And what MathXL asks you to do is to enter it one line at a time. It will be a drop-down menu. And it asks you to use a comma between each leaf. The numbers here are called stems. The numbers here are called leaves. So we got 40 college professors, and we need to first off come up with our stems, like we did a couple of screens ago. Look through here to find the lowest number. I think the lowest is a 22. So oh no, there's a 21. So my stem here will be a 2. And I do notice I've got some 30-somethings, some 40-somethings, some 50-somethings, some 60-somethings, and that's as high as it goes. And then I've got to go through here and get all this information over here in the leaf area. I'm not putting tally marks. I'm actually putting the ones digit that goes with those particular tens digits. So I look through here. I'm on the 2 stem. So I go through here. Here's a 21. So right here I put a 1. And what that stands for is 21. Go through, look for any other ones that begin with 2 right there. So we get a 4 that goes with the 2. And here's another 2 with a 2. All right, for my 30s, let's go through and find any of these. We have a 34. Nothing else here that begins with a 3, beginning with a 3 here, 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 here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then start writing down the leaves. 4, 3, 1, 5, 0, 8, 7, 2, 6, and yes, you do need to write that 8 again. Even though it's a repeat of that 8, it is a separate data point. It needs to be there. Now, you can stop the video and do this all on your own, or you can just look at the completed stem and leaf right here.